Okay, in today's lesson, we're going to just start graphing our square root functions. So if we take a look at the parent function, which is just the square root of x, and we want to plot some points, so remember that we're going to be restricted to a positive domain, or we want non-negative numbers. So I'm going to plug in a 0, and if I square root 0, I'm going to get a 0 out. So if I plug in a 1 and I square root 1, I'm going to get a 1. Now I could plug in a 2, but if I square root 2, I'm not going to get a perfect whole number out, and I'm going to get a decimal. So I'm going to pick perfect squares. So if I plug in a 4, the square root of 4 is 2. I could pick 5, 6, 7, 8. All of those aren't going to give me perfect whole numbers. The next perfect square would be 9, and I would get a 3. So if I plot 0, 0, that's our starting point, 1, 1, 4, 2, and then my graph isn't big enough to keep going, but that's what our parent function is going to look like. Okay, so now if I ask you for the domain, remember that your domain is talking about the x value, so our x's have to be greater than or equal to 0, because if they were under 0, that would give us an imaginary number. If I look at my range, all of my y values, since the graph is opening up, all of the y values are going to keep getting bigger. The smallest y value is 0. Okay, so that's the domain and the range for a parent function. So we're going to start talking about just like a general equation for square roots. All right, and that's going to look like y equals a times the square root of x minus h plus k, where the a, the h, and the k all represent the same things that they have in any other problems that we've graphed. Okay, so the a can tell us if the graph is going to open up or down, if it's going to be stretched or compressed. The h is going to tell us how we're shifting left or right. The k is going to tell us how much we're shifting up and down. So one thing to know about this is that the domain value is going to be x's are greater than or equal to our h. Our range value is going to be y's greater than or equal to k, with the exception unless the graph opens down, then we would say our y's are going down less than or equal to the k. All right, so let's look at an example. So if it says on this one, select the graph for the square root, the parent function, I already told you that it's going to be the domain is going to be greater than 0. The range is going to be greater than or equal to 0. Okay, so we know that that parent function, here was my 0, 0, then I had my 1, 1, then I had my 4, 2. Okay, so we had that curve going that way. So let's talk about end behavior. So what are happening to the y's as the x's approach, and we can select that. Let's go here. Okay. So my y's are approaching positive infinity as the x's are also going towards positive infinity. So as I go to the right, the graph is going to keep going up. Now, if I look at a negative square root of x, that means it's opening down. So instead of, let's use a different color here. So instead of opening up, it would be opening down. So I'd have 0, 0, then I'd have 1, negative 1, and then I would have 4, negative 2. Okay, so my x's are still going towards positive infinity. However, the y's are going to keep going down. So they're going to be under 0 because 0 is the highest y value. And then if I want to look at my end behavior, the y's, remember g of x means the same thing as y. So as the y's are going to negative infinity, or I should say the y's are going to negative infinity as the x's are going to positive infinity. So as I go to the right, the y's keep going down. So then it just says select the correct graph. It says these functions are reflections of each other over the x-axis. So this doesn't match. There would be my answer. And then we could go on to the next question. All right, let's look at another example. So this one wants to know, describe your transformations. So remember, your A tells you two things. It tells you if you are stretching or compressing, and if your graph is going to be opening up or down, and sometimes they'll call the opening down a reflection. So we're going to always say it is compressed vertically. You will never have to say horizontally, but it is going to be compressed vertically by a factor of 1/3. That's our A. Okay, and they are translating it. So remember that if the H is a negative, that you need to change it. So it's actually the H is +4. Okay, so change your H. And then our K is -2. All right, so if we come back to this, they are translating it horizontally 4 units to the right, since it's positive, by 4, and they are shifting it down by 2 units. Okay, let's get rid of that. Okay, let's try another one. Nope. All right, let's look at this one. So if we say that we want to find the domain, sorry, got distracted there. So remember, your domain is always going to be x is greater than or equal to your h values. So our h value, we see a +2, but our h is actually -2. So I would want to plug a -2 in there. And then my k value will always be my range. So my y's are greater than or equal to 3. And the y's are greater than or equal to because it's opening up. All right, let's look at another one. So if I said state the domain and the range on this problem, again, there's my h. I need to always make sure I change my h. So the domain is going to be x's are greater than or equal to 3. And then my k is going to be my y values. And this one is y is less than or equal to -4. It's negative because that a was a negative, so it's going down. All right, so let's look at a different type of question. All right, so this one says select the graph, describe the domain and the range for this parent function, or from the parent function to the g of x. So if I want to talk about the domain, I'm going to say that my x's have to be greater than or equal to, there is no h, so I'm going to say 0. My range values, because this graph is opening down or it's negative, I need to say that the y's are getting less than or equal to, and whatever the k is. All right, so we already know that this is the parent function, starts off at 0, 0, There's 1, 1. Then I've got another point at 4, 2. There would be one up here at 9, 3. So they are reflecting, and then they're also shifting down 2. Or what you guys could do is whatever your H and your K is, that's going to be your starting point. And then if you were like, okay, I want to pick some more numbers, I'm going to plug in a 1 and put a 1 in there. So the square root of 1 is 1, negative 1 plus 2 is 1. And then if I want to pick another number, I'm going to pick another perfect square to plug in. So if I plug in 4, I get the square root of 4, which is 2. So I have negative 2 plus 2, which is 0. So this has a point at 0, 2, 1, 1, 4, 0. So this is the graph that I would want to select. All right, let's see what else we've got here. If I want to talk about this problem, go ahead, figure out where your starting point is, change your H. There's your K. And now if I want to, I know the graph has to open up. If I want to find just, even one more point, I could pick any number that I want. I would pick numbers going up. I could pick a negative 1 if I wanted to. I could pick a 0. You can do whatever you want, but I want that square root to be a perfect square. Okay, so for example, I want it to be like the square root of 4. So I'm going to ask myself, what number plus 2 is 4? And that would be 2. So I'm going to plug a 2 in there. That way I get the square root of 4. The square root of 4 is 2. 2 times 6 is 12. 12 minus 4 is 8. So then I'm going to look for, do they have a point at negative 2, negative 4? Yep. Do they have another point at 2, 8, which would be up here? Looks like it's going to plot there. Let's see. Yep, this one's not plotted at negative 2, negative 4, so it's this first graph. Okay, let's look at one where they have you write the equation. So here's their starting point, which is negative 2 and negative 6. So they got negative 2, negative 6. Remember, this is my H, this is my K. And then they give me this other random point here, which is at negative 1, negative 3. Sorry, I should have called that H. Okay, so that's my H, that's my K. This is just going to be our X and our Y, and we're going to plug it into this equation. Remember that this is the same thing as a Y. So we're going to say our Y is negative 3. That equals, we don't know what our A is. We're going to say the square root. We do know what our X is. Our X is negative 1. Remember, we have to change the H, so it's going to become a plus 2. And then we're going to have our K back here at negative 6. And then we're just going to clean this up. So I'm going to get negative 3 equals A times the square root of 1 minus 6. Square root of 1 is 1. So this is just a 1A minus 6. And then I'm going to add the 6 over. So I get that the A is 3. So my A is 3. My H is going to be a negative 2 in here, which would then turn that to positive 2. And then we would have a negative 6. All right, let's look at, we'll save this one for another video.